writing an exponential function rule given a table of ordered pairs. The table of ordered pairs x, y gives an exponential function. Write an equation for the function. So here's our table of our ordered pairs. I know it's an exponential function, which means I know I'm going to be multiplying or dividing here. So I need to figure out what that pattern is, or what the change is every time. So I can get from 3 to 6 by adding 3 or multiplying by 2, but because it's exponential, I know we're multiplying, because that's like our geometric sequences. So to get from 3 to 6, I multiply by 2. To get from 6 to 12, I multiply by 2. To get from 12 to 24, I multiply by 2. So here I see that common ratio of change is multiplying by 2. Now, in order to write an equation for this, we often think about the phrase f of x equals now times the change raised to the exponent x. Now this is a little bit more confusing than when we were doing sequences, but here's why. This now term is where it starts before anything has happened at all. So for us, that's often the 0 point now. Instead of starting with 1 like we did in sequences, now we're going to be starting with the 0 point because nothing has happened yet. At 0 time, or at 0 steps, or at 0 change, we start at 6. So we're going to have f of x equals 6 because that's where we start before any changes have happened, times that constant change, which is 2, raised to the x power. Now you may remember when we were doing sequences, we often had an x minus 1 right here. But because we're starting with this 0 term now, we no longer need that minus 1. So that's it. So when we plug it into Alex, we're going to put, oh, you know what, on Alex they may ask you to put y equals 6 times 2 to the x instead of f of x, which is fine. So you would put y and you'd push this button for the equal sign, equals 6, this one for the multiplication sign, times this one here to get 2 to the x. And that's it.